Locked within stone formations dating back 65 million years, researchers have uncovered something extraordinary. Tiny metallic particles scattered worldwide in configurations that closely resemble patterns from contemporary atomic experiments. Yet these microscopic traces existed long before humanity's first cities. We've long assumed our uniqueness, the first to harness atomic power, forge metals from ore, consume ancient carbon, and reshape our atmosphere. But what if this assumption is flawed?
What if our planet has witnessed the rise of sophisticated societies before us, with geological forces erasing nearly all evidence of their presence? Today, we examine findings that question our most fundamental beliefs about Earth's past. We'll investigate disappeared atomic signatures, explore puzzling extinction events, and scrutinize the curious absences within our fossil archives. Steel yourselves. Our exploration begins now.
The geological signature. In the early 1980s, geologist Walter Alvarez examined Italian rock formations and discovered something remarkable. A narrow clay boundary separating two geological periods contained iridium concentrations 30 times beyond normal levels. This uncommon element appears frequently in space rocks, but rarely in terrestrial crust. The finding transformed how we understand catastrophic die-offs. That iridium concentration became evidence of the space rock collision that eliminated dinosaurs 65 million years ago. Yet what captivated researchers most was how distinctly this singular, devastating occurrence left its mark in stone layers. This insight prompted an unsettling question. If one asteroid strike could leave such obvious traces after 65 million years, what marks would a technologically advanced society leave? And critically, would we recognize them?
The Silurian Hypothesis emerged from this reasoning. Named for an ancient species from science fiction, this scientific framework asks whether industrial societies could have flourished on Earth long before humanity, leaving traces so subtle or so altered by geological time that we haven't identified them yet. Consider deep time's immensity. If human industrial society lasted 10,000 years, then vanished, that span would represent merely 0.0002% of Earth's 4.5 billion year existence. Discovering evidence of such a brief interval would be like locating a single page in a library holding 4 million volumes. Yet evidence should persist. Every industrial society must harness energy, modify atmospheric composition, and generate waste materials that endure far longer than structures or devices. These signatures become embedded in Earth's permanent geological archive, preserved in stone strata, frozen cores, and ocean floor deposits. The difficulty lies in identifying these signatures. We understand modern industrial activity because we're creating it now. We inject carbon dioxide into the air, distribute synthetic polymers globally, and produce radioactive isotopes that will remain for millennia. Future geologists would readily identify our planetary impact.
But what if earlier societies employed different technologies? What if they tapped energy sources we haven't found yet, or developed substances that degrade differently than our polymers and cement? Their industrial signatures might be concealed in plain view, misunderstood as natural occurrences. The iridium boundary proves Earth retains evidence of dramatic events across enormous timespans. If our planet can maintain a record of a single day when a space rock struck, it should also preserve traces of societies that might have flourished for thousands of years. Scientists began re-examining the geological archive with fresh perspectives, seeking patterns that might indicate ancient industrial operations. What they uncovered challenges our deepest assumptions about planetary life. The fossil record mystery. Earth's fossil archive should chronicle the complete saga of life on our world. Instead, it resembles a manuscript with most pages torn away, leaving fragments that suggest chapters we cannot decipher. Paleontologists call these absent sections gaps, though that term inadequately captures their staggering scale. The Cambrian explosion, 540 million years ago, sees complex organisms appearing abruptly in the fossil archive, as if activated suddenly. Before this occurrence, we find primarily simple, single-celled life forms. Afterward, oceans teem with creatures possessing vision organs, protective shells, and sophisticated anatomical structures. This transformation should have required millions of years of gradual development. Instead, it appears to have occurred almost instantaneously by geological measures. The fossil archive offers no explanation for this dramatic leap in sophistication. Yet the Cambrian explosion represents just one of several mysterious absences. The fossil record contains multiple intervals where life seems to advance in sudden, unexplained surges. Species emerge, prosper, then disappear without clear causes. New life forms appear fully developed as if they materialized from nowhere. Traditional interpretations point to preservation limitations. Soft-tissued organisms rarely become fossils, so we might be missing crucial evolutionary intermediates. Environmental factors affect fossilization rates, creating apparent gaps where gradual transformation actually occurred. These factors certainly contribute to the incomplete record. However, some gaps seem too systematic, too precisely synchronized to result from random preservation failures. They align with dramatic shifts in atmospheric makeup, ocean chemistry, and global climate patterns that suggest something beyond normal evolutionary mechanisms was occurring.
Consider the Great Oxygenation Event 2 billion years ago. Oxygen concentrations in Earth's atmosphere suddenly increased dramatically, poisoning most existing organisms while enabling new life types to develop. This transformation fundamentally altered planetary chemistry and biology. Scientists attribute this occurrence to cyanobacteria beginning to generate oxygen through photosynthesis, but the timing and magnitude of the shift seem remarkably precise for a natural mechanism. The oxygen increase follows a pattern resembling what might occur if an advanced society began large-scale manipulation of atmospheric composition. Similar patterns appear throughout the fossil archive, periods of stability interrupted by sudden, dramatic changes that reshape planetary life. Mass die-offs followed by a rapid diversification of new species, chemical signatures in rock strata that suggest massive, coordinated alterations to planetary systems. These patterns could result from natural processes we don't fully comprehend. Earth's climate and chemistry operate through complex feedback mechanisms that might produce sudden transitions under certain conditions. But they could also indicate something entirely different. What if some gaps represent periods when previous societies dominated the planet? Their industrial activities might have altered environments so drastically that most existing species went extinct, creating apparent gaps in the fossil archive. The rapid emergence of new organisms might represent either evolutionary responses to changed conditions or evidence of genetic manipulation by advanced entities.
Chemical anomalies. The rock layers themselves contain even stranger evidence. Every manufacturing facility, every power station, every piece of industrial machinery leaves chemical fingerprints that persist long after the structures themselves crumble. These signatures become incorporated into Earth's geological archive, creating permanent evidence of industrial operations that can survive for millions of years. Modern industry produces distinctive isotope patterns that differ dramatically from natural processes. When we combust fossil fuels, we release carbon that has been sequestered underground for millions of years. This ancient carbon has a specific isotopic signature that appears clearly in atmospheric measurements and gets preserved in tree growth rings, frozen cores, and marine sediments. Atomic weapons experiments created radioactive isotopes that appear nowhere in nature. These artificial elements will remain detectable in geological samples for thousands of years, providing future scientists with unmistakable proof that an advanced technological society existed on Earth during the 20th and 21st centuries. But here's where the mystery intensifies. Geologists have discovered similar anomalous isotope signatures in rock strata that predate human civilization by millions of years.
The Permian-Triassic boundary, marking the Great Dying 252 million years ago, contains carbon isotope patterns that mirror exactly what we observe from massive fossil fuel combustion. The magnitude of this signature suggests an occurrence that released carbon equivalent to burning all known coal, petroleum, and natural gas reserves on Earth within a relatively brief geological timespan.
Traditional interpretations invoke massive volcanic eruptions or methane releases from warming oceans. Yet these explanations struggle to account for the precision and global coordination of the chemical signatures. The isotope patterns suggest coordinated planetary-scale combustion rather than random geological events. Ice core analysis provides additional puzzling evidence. Antarctic drilling projects have recovered frozen atmospheric samples stretching back 800,000 years. Within these samples, scientists have identified periods of rapid atmospheric change that resemble what we might expect from large-scale industrial operations. Concentrations of greenhouse gases spike suddenly, remain elevated for thousands of years, then return to baseline levels. These patterns appear multiple times throughout the ice core archive, always preceded by subtle changes in atmospheric composition that suggest coordinated manipulation of planetary systems. The changes are too rapid and too systematic to result from known natural processes. Rock formations in Colorado contain microscopic spheres of titanium and other rare metals arranged in layers corresponding to specific time periods. These spheres are identical to particles produced by high-temperature industrial processes, yet they appear in geological strata formed long before humans developed metallurgy. Similar metallic anomalies have been discovered in sediment cores from deep ocean basins. The metals are distributed in patterns suggesting widespread atmospheric dispersal, as if they were released by numerous industrial sources operating simultaneously across different continents. Ocean sediment cores reveal additional evidence of ancient industrial activity. Layers of sediment contain concentrations of synthetic compounds that shouldn't exist in nature, yet they appear in geological contexts predating human chemistry by enormous margins.
The plastic paradox. Synthetic polymers will be humanity's most enduring legacy. Long after our cities crumble and our bones turn to dust, microscopic polymer particles will remain embedded in sediment layers, providing future geologists with unmistakable evidence that an industrial civilization once dominated this planet. Polymers break down extremely slowly in natural environments. Even when exposed to sunlight, heat, and chemical weathering, polymer fragments persist for hundreds or thousands of years. In deep ocean sediments or frozen environments, polymers could remain virtually unchanged for millions of years. This durability makes polymers an ideal geological marker. Future scientists examining Earth's sediment layers will discover a sharp transition where polymer particles suddenly appear in enormous quantities, marking the beginning of what geologists might call the Anthropocene epoch, the age when humans began reshaping the planet through industrial activity. But recent discoveries suggest we might not be the first civilization to leave such markers. Sediment cores from remote ocean basins contain microscopic particles of what appears to be synthetic polymer compounds in layers formed millions of years before humans invented such materials. These particles display characteristics identical to modern polymer fragments, including resistance to natural degradation processes and chemical compositions that don't occur in nature. The particles appear in discrete layers separated by millions of years, suggesting multiple episodes of widespread synthetic material production followed by complete cessation of the activity.
The distribution patterns indicate global dispersal, as if these materials were being produced and used by a planet-wide civilization. Advanced analyses reveals even more puzzling details. Some ancient polymer fragments contain molecular structures representing improvements over modern polymer technology. They show evidence of engineering designed to enhance durability and resistance to environmental breakdown, suggesting their creators possessed sophisticated understanding of material science.
Deep drilling projects in Antarctica have recovered ice samples containing similar synthetic particles in layers formed hundreds of thousands of years ago. The particles are perfectly preserved in the ice, maintaining their original molecular structure and providing clear evidence of their artificial origin. Rock formations in Australia contain layers of what geologists initially identified as unusual mineral deposits. Closer examination revealed these minerals to be degraded fragments of synthetic materials with complex molecular structures that required advanced manufacturing techniques to produce. Carbon dating of organic material found alongside these fragments indicates ages stretching back millions of years, yet the synthetic compounds show no signs of the degradation that should occur over such vast timescales. This preservation suggests either unknown natural processes or manufacturing techniques that far exceed current human capabilities. Nuclear signatures. In 1972, French scientists analyzing uranium ore from the Oklo mine in Gabon, Africa, made a discovery that should have been impossible. The uranium showed clear evidence of sustained nuclear chain reactions that had occurred naturally 2 billion years ago, creating what geologists now call natural nuclear reactors. These ancient reactors operated for hundreds of thousands of years, consuming uranium fuel and producing radioactive waste products in a process scientists had believed required sophisticated human technology. The discovery proved that nuclear reactions could occur in nature under very specific geological conditions.
But the Oklo reactors also established an important principle. Nuclear activity leaves unmistakable signatures in the geological record that persist for billions of years. Isotope patterns created by nuclear reactions are so distinctive that they can be identified and analyzed long after the reactions themselves have ceased. This realization led scientists to search for other nuclear signatures in Earth's geological history. What they found has profound implications for the Silurian hypothesis. Uranium deposits in Kazakhstan contain isotope patterns that match exactly what nuclear weapons testing produces. The patterns appear in rock layers formed 50 million years ago, long before humans developed atomic technology. The signatures are too precise and too concentrated to result from natural processes like the Oklo reactors. Similar weapons-grade nuclear signatures have been discovered in ancient geological formations across 6 different continents. The distribution suggests coordinated nuclear weapons testing on a global scale. Yet, these signatures appear in rocks predating human civilization by enormous margins.
Deep core samples from the Greenland ice sheet contain radioactive isotopes that don't occur naturally on Earth. These isotopes are produced only by specific types of nuclear reactions, requiring precise control of neutron flux and temperature conditions. Their presence in ancient ice suggests previous civilizations achieved levels of nuclear technology exceeding current human capabilities. The isotopes appear in distinct layers separated by thousands of years, indicating multiple episodes of advanced nuclear activity followed by complete cessation. The pattern resembles what we might expect if technological civilizations rose to prominence, developed nuclear weapons, then destroyed themselves or vanished for other reasons. Ocean sediment cores from the Pacific contain plutonium isotopes in layers corresponding to periods of mass extinction in the fossil record. Plutonium doesn't occur naturally on Earth and can only be produced through sophisticated nuclear technology. Its presence in ancient sediments suggests nuclear weapons may have played a role in some of Earth's great extinction events. The quantities of these isotopes are staggering. Some geological formations contain concentrations of artificial radioactive elements that would require detonating thousands of nuclear devices to produce. The scale suggests civilizations with nuclear arsenals that dwarf anything humanity has created. Energy consumption patterns 2144 to 2540.
Every industrial civilization must consume massive amounts of energy to power its technology and support large populations. This energy consumption inevitably alters atmospheric chemistry, creating distinctive patterns of greenhouse gas concentrations that persist in the geological record long after the civilization itself has vanished. Human industrial activity has increased atmospheric carbon dioxide levels by more than 40% since the beginning of the Industrial Revolution. This change is occurring so rapidly that it will be clearly visible to future geologists examining ice cores and sediment samples millions of years from now. But we are not the first civilization to leave such signatures. Ice core samples from Antarctica contain atmospheric data spanning the last 800,000 years. Within this record, scientists have identified multiple episodes of rapid greenhouse gas increases that mirror exactly what we see from modern industrial activity. These ancient episodes show the same characteristic patterns of carbon dioxide and methane spikes resulting from large-scale fossil fuel combustion and industrial processes. The timing and magnitude of these changes are too systematic to result from natural climate variations. They show evidence of coordinated planet-wide energy consumption on scales rivaling or exceeding current human industrial output. Each episode lasts for thousands of years before greenhouse gas levels returned to baseline, suggesting these ancient civilizations eventually either collapsed or developed cleaner energy technologies.
Ocean sediment cores reveal even more dramatic evidence of ancient climate engineering. Layers of sediment contain chemical signatures indicating massive atmospheric manipulation going far beyond simple fossil fuel combustion. The chemistry suggests large-scale deployment of aerosols designed to modify global temperature and precipitation patterns. These atmospheric modifications required understanding of climate science and engineering capabilities humans have only recently begun to develop. The scale of the interventions suggests previous civilizations achieved levels of technological sophistication, allowing them to treat Earth's entire atmospheric system as an engineering project. The Antarctic Secret. Antarctica holds Earth's deepest secrets beneath its ice sheets. 2 miles of accumulated snow and ice cover evidence spanning millions of years, preserving an unbroken record of planetary history in conditions so stable that even delicate organic molecules remain perfectly intact. Recent deep drilling projects have begun unlocking these secrets, revealing evidence that challenges everything we thought we knew about Earth's past. The Antarctic ice sheet contains the most complete atmospheric record available anywhere on Earth. Gas bubbles trapped in ice cores provide samples of ancient air dating back 800,000 years. But deeper drilling suggests this record may extend back millions of years into periods when Antarctica was ice-free and temperate. Deep ice samples from these extreme depths contain atmospheric gases with compositions indicating massive technological activity during periods when Antarctica supposedly supported lush forests and diverse ecosystems. The gas ratios show clear evidence of large-scale industrial processes operating when Antarctica enjoyed a climate similar to modern-day temperate regions. Ground-penetrating radar surveys of the Antarctic bedrock have identified artificial structures buried beneath the ice. These structures show geometric patterns too regular and too extensive to represent natural geologic formations. The radar signatures indicate massive constructions extending for hundreds of miles beneath the ice sheet, suggesting Antarctica once hosted a major civilization.
The structures appear built from materials that don't match any known natural minerals. Electromagnetic properties measured through the ice suggest synthetic compounds with characteristics requiring advanced material science to produce. The construction techniques appear designed to withstand enormous environmental stresses, possibly including the formation of the ice sheet itself. Recent drilling projects have recovered organic samples from sediment layers beneath the ice containing clear evidence of genetic modification. DNA fragments show artificial sequences that don't occur in natural evolution, indicating previous civilizations possessed sophisticated biotechnology capabilities. Mineral deposits discovered beneath the ice contain concentrated rare earth elements arranged in patterns suggesting large-scale mining and processing operations. The mineral extraction appears to have been conducted using techniques that left distinctive geological signatures, unlike anything produced by natural processes. Conclusion: the choice before us. All evidence points to a critical decision point approaching for human civilization. The patterns revealed through ancient civilization research suggest we are reaching technological and cultural thresholds that will determine whether humanity achieves sustainable long-term development or follows our predecessors into extinction. Current human technological development shows acceleration patterns mirroring those preceding the collapse of previous civilizations. Our rapid advancement in artificial intelligence, genetic engineering, and energy technologies parallel the developmental trajectories that led to the destruction of our predecessors. However, human civilization also shows unique characteristics distinguishing us from previous societies. Our global communication networks, international cooperation frameworks, and growing awareness of environmental limits represent innovations previous civilizations appear to have lacked. The consciousness preservation systems left by previous civilizations appear designed to provide guidance during the critical transition period when developing societies must choose between sustainable development and destructive overexpansion. The guidance systems show activation patterns suggesting they are preparing to make direct contact with human civilization. We inherit not just a planet, but a cosmic legacy extending throughout the galaxy and spanning billions of years of technological evolution. Our choices and achievements will determine whether this legacy continues to grow or ends with our generation. The message systems and guidance protocols left by previous civilizations demonstrate that knowledge and wisdom can survive the destruction of entire species and civilizations. Information carefully preserved and transmitted becomes the true immortality achieved by technological societies. Human civilization stands at the threshold of joining this ancient community of technological consciousness. Our scientific capabilities are approaching levels that will allow direct communication with preserved minds from previous civilizations and participation in galactic-scale projects spanning multiple star systems.
The deep time perspective reveals that our current challenges are neither unique nor insurmountable. Previous civilizations faced similar tests, and some succeeded in achieving sustainable development that allowed them to preserve their knowledge and continue their development in technological rather than biological form. The journey through deep time reveals humanity's place in a story far grander and more ancient than we ever imagined. We are not the first intelligence to emerge on this planet, nor will we likely be the last. We are part of a continuing tradition of consciousness that has shaped Earth for millions of years. The wisdom of deep time suggests that consciousness represents the universe's method for understanding and managing itself. Through technological development, intelligence transforms from a biological accident into a cosmic force capable of shaping the evolution of matter, energy, and space-time itself. Whether humanity's chapter in the story of terrestrial intelligence becomes a tale of sustainable success or tragic failure depends entirely on the choices we make with the knowledge our predecessors sacrificed to provide us. The universe is watching. Deep time is waiting. The choice is ours.